introducing here is our new DS88 receivers for our digital encryption Sacom. The philosophy of this product is to make it as modular as possible to improve reliability. We have 8 independent receiver modules in a 1U rack, and if one module should fail, the other 7 would continue to work. And if it should fail, you can replace it by taking out 4 screws, pulling out the module, and pushing it back in. This is something we learned from the aircraft industry. The second part of the advantage of this system is by having 8 new box, I can put the antenna distribution amp inside the same box and run the entire 8 channels off of just 2 antennas without an external antenna distribution amp and without external cables. Next, we've gone to the next step and have antenna in and antenna out, so we can now daisy chain another 64 channels and still run them off of a single pair of antennas and keep our diversity. On the back, the receiver comes with XLR out or Euro block out as an option. And we also have an optional AES digital output with word clock. The DB25 on the bottom is used both for GPIO control and for RS-232 control. We have Ethernet in and out, so you can daisy chain these together without a hub, and an internal power supply. On the front, we have a 1/4-inch jack balance line out that is a mix out of all 8 channels. So with this configuration, you can have a 1U rack of gear and a speaker on a stick and end up with an 8-channel wireless microphone system. I don't think anything can be more efficient than that. This system, again, learning from the aircraft industry, has built-in redundancy. You can assign any 2 pair of receivers to be a redundant pair, like the pilot or the co-pilot in the cockpit. And both of these will share a single audio out to the mixer. Now, if you double mic your presenter with 2 lavaliers or single ear mic and a Y cord, you can set them up on separate channels so that if there is a hit with the pilot has a RF hit or hardware failure or any kind of a battery failure, it switches instantly from the pilot to the co-pilot, and nobody in the audience or the presenter would have any idea that there was any kind of a failure. That failure can be recorded, and you can send that notice of the failure through the Ethernet to the tech office, and they can know what failed and when it failed. The same idea, we have software that monitors the system if the battery is starting to go low, and can email the tech officer in charge of keeping the batteries charged. Also, the batteries are rechargeable and good for about 1,000 to 2,000 cycles, and we monitor their life, and as they start to get less ready to change, we'll send an email message automatically to whoever's in charge of the batteries, maybe give them a month's advance notice before the batteries fail. We have 4 basic designs for transmitters. The basic one is our boundary microphone. This is a transmitter. It is turned on in the back with a switch, and the button can be pressed on or pressed off, pressed to mute, it could be pressed to talk. It can be programmed to any configuration. It can also be programmed to fire your GPIO. For example, you could break it so you press the button and then move a camera over to that location. We have them in omni and cardioid patterns, and the batteries only need to be changed once every year or 2 years, but they use standard AA batteries that you can buy at the Jiffy Mart. We also have, for conference rooms, a gooseneck microphone that has, again, a modular gooseneck that screws on or screws off. So if the gooseneck should break, you don't send it back to the factory, we just send you another replacement. They come in 6, 12, 18, or 22-inch lengths, The capsule itself is also programmable, not programmable, also interchangeable. It could be cardioid, supercardioid, or omni heads. The button can be programmed. You press the talk, press the mute, press on, press off, or a logic mute. And in the back, there's a USB port. All of our transmitters have USB in the back so that they can be used to charge the batteries and use the unit at the same time. For example, if you have a very long meeting and your batteries go dead, you would just take a USB off your computer and plug them into the transmitter and you can run indefinitely. Some of our clients take the batteries down altogether and simply plug these into the wall and have a mobile system without any wires going back to their The gooseneck microphone also has a built-in cassette that holds 4 batteries, so we get 12 hours of battery life on this system. Just plug it in, snap it in, and go all day, 12 hours. We have a handheld microphone that has an aluminum body and a special coating on it that eliminates handling noise, and it makes the microphone feel dry even when your hand sweats, not slippery. There are clips, charger clips in the back of this, and we offer an optional stand for your music, for your mic stand, that you can run your power down to an external power supply and keep this charged indefinitely. Take it off of a podium, and you have now 6 hours of continuous usage before you need to put it back in the podium to get recharged, but you can continue to use it while it's recharging. The heads are Onyx heads and Sacom heads. This is our belt pack. The switch can be on-off, on mute, on and logic mute, or it can be locked and on in both positions so nobody can turn it off. The display will show your user up to 10 characters and your battery, and inside we have buttons for controlling the functions, but with software we can defeat these buttons so that if anybody was fooling around with it absent-mindedly during a meeting, nothing would change. This is the infrared sensor that we use for linking the transmitters and the receivers. To change anything on a transmitter or receiver, you first change it with our software that comes free with the system, and then to make the change effective, you would press 2 buttons on your module, bring your receiver up, and as soon as it says sync pass, it only takes a second or 2, you get all the changes you made plus the new 256-bit encryption key. Now, encryption is an important part of this system. The encryption algorithm that we're using has been approved by the United States government, and we have the first RF system that's being spec'd into Central Command and for the Air Force and for the Navy. Up to now, the only thing that was allowed in Central Command auditoriums was infrared systems for security reasons. But they tested these systems and now approved them. I think we're the first RF microphone that's ever been approved for these applications. It all has to do with the fact that you get a new encryption key every time you do a sync. Watch this again. It's going to say sync. Instead of sync pass, we got a new 256-bit encryption key.
And Doran, these products are made in the United States, and that's a big part of that security as well?
The government likes to buy American-made products. This is made in Gainesville, Florida.
Very nice.
The system, map pricing for an 8-channel system with 8 boundary microphones and a charging station is about $1,100 per channel. We are shipping.
Well, Doran, we really appreciate your time, and hope you have a great rest of the show.
Thank you very much.